Okay, welcome back, Algebra 1 students. Here we go. Lesson 3-6, video 2, still covering lines of best fit or lines of fit here. All right, so let's take a look at this one. It says the graphic shows regional air travel data recorded by a domestic airline company. How can you use the data to estimate the number of air miles people flew in 2003? If the trend in the air travel continues, what is the reasonable estimate for the number of miles that people will fly in 2030? Okay, all right, so let me drag this out of the way if I can. All right, so it's up here. Okay, so we are going to need to come up with, we're going to come up with the line of best fit for this problem. All right, so over here, we have our x and y variables here. So first you have air miles traveled in miles. This is your y. These are your y's. Okay, so these are your y's. Right? That's what we're measuring. Time is typically x. So time is our years. Now, the one thing I want to change is for these, I want to let 1975 be year 0. Right? Typically, we don't like to work with these big 4-digit numbers. We'd rather work with like the single-digit numbers. So let this be years since 1975. So if this is 0, then 1980 is 5, 85 is 10, 90 is 15, 1995 is 20, 25, 30, 35, and 40. So you can see we're counting by 5s, right? Okay, so the first thing we'll do is we'll use Desmos to find the line of best fit. So we're going to find line of fit. Right, and that's going to be in Desmos. So I have my data here on my piece of paper. So you do as well. So let's type it into Desmos, and again, we'll probably finish that at Desmos. Before we go, though, let's talk about these two words. So this first is interpolation. So that's what we're doing here. We're taking known values and we're interpolating, right? We're going to take another value, plug it in, and see what we get out as our estimation value. Now, sometimes there's also things called extrapolation. So extrapolation is when you use a model to make a prediction outside the range of no values. So notice this says 2003. 2003 is right smack dab in here, right? So that would be an interpolation. But then 2030 is way out here after 2015. This is called an extrapolation because it's extra, it's on top of. Sometimes extrapolations are not accurate, so you have to be careful, right? Because this data, this model is going to be used or is fitted to this data, not extra data outside of it. So we'll talk about that as we go through. So again, first thing is we're going to do is go to Desmos and get this line of best fit. Okay, so here's Desmos. We're going to add a table. By now, hopefully you're good at this. We're going to let x be those years 0, 5, 10, 15, 20, 25, 30, and 35, and 40. Okay? And then the years, oh, not 45, sorry. And then the years, or not the years, the miles. So again, this is in thousands of miles. So this 1298, that's actually 1,298,000 miles. It's 12. Yeah, you had 3 zeros, so 1 million. And then we go 1529, and then we go 1720, and 2118, and 2387. Again, just copying the miles, and 2697, not making a mistake, and 2973, and 2945, and 3055. Right, so I got all the data in there. Hopefully I didn't mistype anything. And now we're going to find our line of best fit. So Y, shift minus key, 1. Arrow to the right. Shift squiggle button, right? MX, shift minus key, 1, arrow to the right, plus B. And here is our line of best fit equation. I'll just use the numbers they give us. So our line of best fit here is Y equals, our slope is 47.87, 47.87x plus, and our B is 1345.04. So this is our equation that we're going to use. All right. So first, how many miles will be traveled in 2003? Well, to find that x value, we must take that away from 1975. So we're going to do, so to find x, we're going to do 2003 minus 1975, and you get 28. That is the x value. So we're going to plug that into our equation. Y equals 47.87 times 28 plus plus 1345.04. And you would just type all this into Desmos as it looks, and you're going to get 2685.4. And that's in thousands of air miles. So 2685.4 thousands air mile. 1,000 air miles. 1,000 air miles. So again, that's like 2,685,000 air miles, right? So 2,685,400 air miles. 685. That's a 5. So that's it. Okay, that's what that number represents. Okay, so sort of, I mean, you can see it's around the data, right? Right snuggle in there on the airplane. But now let's do, what about the year 2030? Well, now to find the x value, we need to take 2030 and subtract 1975. This, when you subtract, gives you a difference of 55. So now when you plug this in, y equals 47.87 times 55 plus 1345.04. I got something like 3977.89. Again, just use your calculator, type all that at once. And that is 1,000 air miles. So again, that's like 3,977,890 air miles. And you can tell that's way above, right? That's growing really fast. So this might not be accurate, right? So you just have to be careful. This might not be reliable. Might not be reliable. Not reliable. And again, it's because that you're using a year outside of the range that they gave you, all right? And that's called extrapolation. Just be careful. Nice. Okay, let's talk about a couple problems and then we're done. I know this is some heavy stuff. I get it. So just keep doing your best. Okay, so let me clear that. Bring this back down. Okay, let's get after it. Oh, it was there. All right, example 5. A student found a positive correlation between the number of hours of sleep his classmates got before a test and their scores on the test. Can he conclude that he will do well on the test if he goes to bed early? So there's this idea of correlation and causation, right? So causation describes a cause and effect relationship. A change in the one variable causes a change in the other, right? But the idea is that even though two things are related, right? A correlation is like a relationship. Even though hours of sleep and test score are related, is there a cause and effect? Does your sleep cause a good or bad test score? And typically, the answer to these questions is not necessarily, right? They're gray area. They're not black and white. Not necessarily. Not necessarily. And the problem is there's other variables that are in play. So other variables. So sleep, definitely very important, right? Before you have a test, you should get sleep, right? If you're sleep deprived, taking a test makes it harder. But there's other variables, like what goes into studying, what goes into creating a good test score. Well, what about studying, right? Other variables such as time spent studying. Could affect how well he does on the tests. Could affect how well he does on the test. Okay, so again, you can't just say, oh, if I get a whole bunch of sleep, I'll do really well. There's other things that affect things. All right? It's this idea of correlation does not imply causation. All right, last one here. A lifeguard notices that as the outside temperature rises, the number of people coming to the beach increases. Can she conclude that the change in temperature results in more people going to the beach? Well, of course, right? If it's hot, people go to the beach. If it's cold, they don't, right? Yes, there's a general relationship there. But again, there's probably other factors to why beaches are crowded. So we say not necessarily. Other variables. Other variables such as, and one they gave here was time of year, right? Time of year. And again, the idea is when people go on vacation, right, during the spring breaks, during the summer months, right? So such as time of year could affect how many people go to the beach. How many people go to the beach? Okay. So again, correlation does not imply causation. There's too many other variables involved, right? Life's too complicated just to pinpoint one thing that causes another. All right. Okay. So thanks for watching. I know this was kind of a hectic lesson, but do your best. And if you're intrigued by this stuff, you might want to take stats as you go through the high school. All right. Thanks for watching.